I have 100 students in the classroom, yeah? And what I have is, I have information about their height, I have information about their weight, okay? What I'm trying to do is build a model which shows me the relationship between height and weight, okay? How do I do that? Essentially, think of a graph, yeah? And everybody here has done some level of Cartesian geometry. You know what a graph is. Yeah, Cartesian geometry. See, that's the wonderful thing about coming to somewhere like IIT. Do you know Excel? No, I don't. Are you comfortable with Cartesian geometry? Of course I am. That's a good thing. Okay, I'll live with that. Okay, and here we have weight, and here I have height, and these are all the data points that I see. Yeah, this is kind of what it looks like, and this is 4 feet, and this is 5, and this is 6, and all right. Fine, we'll move around the scale a little bit, yeah? And these are kilos, 30 and 40 and 50. Now what I have here shows the relationship between height and weight. Everybody with me on that? Yes, no? Kind of? Everybody's seen a graph like that. Right? The question that I'm trying to answer here is, if somebody else walks into my classroom right now and says, hey, I'm 6 feet tall, I should be able to predict what their weight is. Right? There are a variety of ways to do this. Okay? But this is essentially what every predictive model is trying to answer. There are two kinds of predictive models. This is the most important one. Right? And in linear regression model, I draw a line like this, okay, which gives me essentially the correlation between height and weight. Everybody knows correlations, right? Everybody comfortable with correlation? It's a little different, but it's kind of the same thing in many ways. Okay. Now, if somebody comes in and says, hey, I'm 6 feet tall, all I'm going to do is figure out what this point is and say, hey, you're 65 kilos. Okay. What that straight line does is it shows me the relationship between height and weight for everybody who is in the classroom. Right? Now the question is, where does this train versus test data set come from? Okay. When you go to a Kaggle contest or when you look at our contest, you'll see that there's a training data and there's a test data. Now what Aspiring Minds did was, they ran this survey on 4,500 students. Okay? They ran this survey on 4,500 students, and on one axis they had salary, and in the other axis you might have anything. It can be your GPA, it can be your salary, and it can be something else. Let's say which college you went to. It can be salary and your, 10th grade GPA. And how are they connected to each other? That's the question that I'm trying to answer. That are they related or not? Is your salary outcome today, how much you're going to make, does it depend on your GPA 6 years back, on your 10th grade GPA? Right? Maybe it does. Maybe it shows something about you as a person, right? That you were a hard worker right from the age of 15 or 16, and that is going to show up in your, in your 10th grade GPA and also in your first salary. Yeah. Now, one thing that I realized very early on is that I'll never get a job at Infosys. Okay. Never. They will never give me a job because they have a cutoff of 70%, 60%, 70%, something like that. If you did not make 70% in all your exams, right? Your 10th grade, 12th grade, undergrads, graduation, whatever you did after that, unless you have 70% in all of them, we won't give you a job. So, so they really believe that. They believe that your 10th grade or 12th grade or your undergraduate degree, the percentage marks that you get, that actually shows whether you're going to be a good performer in, coding, I don't know, Java or not. Right? So they would never give me a job, unfortunately. Okay, so these relationships are very, very important to us. And the good thing about a regression model, which is why we have a regression model, because the question at this point that you can ask me is, this looks like a correlation, right? And everybody has seen a correlation. How does height increase based on my weight? How does weight increase based on my height? How does my educational performance increase based on my GPA? I can run a correlation. Excel will do that for me, right? Why do I need a regression model? Okay. Why do I need a regression model at all? Why do I need these advanced modeling techniques and all of that when all I can do is run a correlation? Anybody? We have correlation, and let's say the correlation between 10th grade GPA and salary is 0.9, which means that, you know, if your 10th grade GPA goes up by, you know, whatever, 10%, your salary goes up by 9%, something like that. Okay, let's say that relationship holds true, and if your undergraduate GPA goes down by 5%, your salary also goes down by 5%, in which case I would have been making no money right now. But this is a correlation. Why do we need a regression model again? Okay, but let's say I have correlation and my correlation is 0.9, and can't I say that if my 10th grade GPA was 60%, okay, I had a salary of, let's say, 1 lakh. As it keeps on increasing from there, for every percentage increase, my salary increases by 0.9. Perfect, right? That's the easy answer. Absolutely. Technically, there's a little bit of a difference, but this is a fantastic answer. Multiple variables. In a correlation, I can individually say my salary depends on education, right? My salary, educational institution. My salary depends on my 10th grade GPA. My salary depends on my undergraduate GPA. My salary depends on my gender, right? Whether I'm female. And it does, unfortunately. But they are individual, they're separate correlations. In a regression model, you can put all of them together in one big model, okay? And each one of those coefficients can tell you that how much these different things affect your salary outcome, all right? So how much does your undergraduate GPA, how much would that increase or decrease your salary? How much would your being male or female increase or decrease your salary? What's the effect of your gender on your salary? You can actually look at all these variables together in a single model and come up with a much harder quality, much better quality prediction. All right? Okay. Now, where are we on that R stuff? Everybody downloaded that? Is it working? Yes? No, you cannot say that one-on-one because it's not a first-degree differential. Absolutely. But you can show that a correlation of 0.1 would mean that if something goes up 1, how much does the other one go up? Right? I'm not saying it's causation. You can never, unfortunately, come up with causation. But correlations, right? You can say that 0.7, 0.9, any number. Yeah. We can talk about that. All right, how are we doing on R? Could everybody install it? Yes? Yeah, fantastic. Okay, so if you have RStudio installed, then let's go directly to the code. Yeah, I think we have R installed. That's fantastic. Okay, let's go good. Thank you very much. All right. Okay. If you open RStudio, this is kind of what you would see. Yeah. I'm gonna clean up my environment as well. Okay. Do you see this? Does everybody see this when you open RStudio? Yes, no, maybe, kind of. All right. Everybody sees something like this. Okay, fantastic. Now, do me a favor. That code that you had, that you could get to on RFiddle, would you mind copying and pasting it here? Just open a file and just copy it and paste it. Okay. So what are we trying to do here, yeah? We're going to do exactly what we discussed. We're going to try and run a regression model to begin with and see the relationships between your salary outcome and a variety of attributes of that person, yeah, of that student who we have interviewed. Okay. Everybody on RStudio and everybody could copy and paste that code in there? Yes? No? Maybe? Yes? All right, fantastic. Now do me a favor, select these first 8 lines of code and go run. Okay. Cancel it because I've already installed these packages. Okay, the upside and downside of R. The upside of R is that it's completely driven by a community. Yeah, that's kind of also its downside. But the upside is that it's driven by community, and people can design packages for a variety of languages for whatever that they think is useful, and get it vetted by a group of peers and upload it so it can be used. Yes. Sorry. Oh, it was not there. Okay. All right. So let's see. Actually, I can. Yeah, so the rest of the code you have with you, yeah? Awesome. That's great. Oh, come on. Okay. Right. Just copy it, paste it, make sure the bullet points are not there because you don't need the bullet points. Okay. So I'm just installing these 4 packages and telling R that I'm going to use these, all 4 of these libraries. Okay. And once that's done, I'm good to go. Now coming back to our train and test data. Right? So what Aspiring Minds did was they interviewed about 4,500 students who graduated from different engineering colleges. And they broke up the data, separated the data into 2 parts, right? One on 3,000 students and one on 1,500 students, okay? The 3,000 student data essentially allows you to create your model, all right? And figure out that how each of the attributes that you see in there affect the final outcome, your dependent variable, which in this case is salary, okay? And then, once I have that model ready, what I want to do is predict on other students, right? Because if I predicted on those same very students, then I'll just be fitting the model. I won't be predicting anything. I have those students, I run the numbers, I come up with, you know, how X affects Y or how A affects B. I know that, yeah? But my idea is that I want to predict somebody who's not a part of that system. So how important each one of those attributes are I model it out on the trained data set, okay, and then test it out on the test data set which has not been used when creating the model. All right. So that's why we split it up into two different parts. Once we have run the model on the test data set, we submit it on the online platform here, and it tests for how good or bad your model is. Okay. It uses something called the root mean squared error. All right. So where we are on the installation of packages, are we done with those? It works? Okay. If you have any issues, let us know. Yes. Did you do the install first? Okay. If the other way you can do the installation. There's tools here. You go to tools, you go to install packages, and type in the name of the package. Okay. And press install, and it should do the same thing. Everybody has the code, right? Because it's highly annotated. Every line of code that I write, best practices. You're still students. Remember, if you ever write a line of code, make sure you comment on it. Yeah, it's easier for all of us to understand later. Otherwise, it screws things up a little. Okay. All right. Now this first line of code, that's line 16 there. What it does is it asks R to read the CSV file, the training file, right? That's my first step. I want R to read the file. Okay? I want R to read the data. Line 17 does the same thing for the test data. Okay. One thing to note here, yeah, and this is when you look at the data file, it will become very clear, is that there's line 11. That's your usual command to import data sets into R. Okay? Line 11 is your usual command for importing data sets into R. The reason why we don't use it, I'll show it to you right now, is this guy. If you look at the data set, you will see that wherever there's a missing value in the data set, it's been replaced by a -1. Okay? Now, anybody who works in data sciences or analytics, they'll tell you that however great your modeling skills are, you still end up spending anywhere between 50 to 80% of your time cleaning data. Okay? It's not cool. It's not fun. All right? It's a lot of very boring, mundane work. So whenever, the Harvard Business Reviews of the world say that, hey, data science is the sexiest profession of the 21st century and so on, next time you meet Davenport, yeah, Tim Davenport, next time you meet him, you tell him that, hey, look, man, you said it's pretty sexy, but I spend 70% of my time cleaning and scrubbing data. Okay? Not fun. But somebody's got to do it, and you're usually going to be the one after you go out of college and do something like this. You're a first-year analyst. This is your job, right? Okay. All right. So because what they did was they replaced all missing values with the number -1, we made a small tweak in the code, and instead of using the usual line of code, which is what I would have, that na.strings is equal to blank, which says that anything that's blank is na, which is what R uses to realize that there is a missing value. All I'm telling R here is that anything that's a -1 is essentially a missing value. Okay? Now, because otherwise R will act up. It wouldn't know what to do with the -1s. It will think of those as numbers. All right? And we don't want that. Okay. All right. First step, data cleaning. Okay? Before we go on to cleaning the data, some of it I cleaned a little bit in Excel, And I'll tell you why. Okay, a couple of things that I did clean in Excel. One was the board, which board the student went to, and the other was specialization. Okay, and the reason why I did this manually instead of trying to write a few lines of code is that your specialization is called something else in different engineering colleges. Yeah. So in IIT, I don't know, maybe it's called electronics and telecommunication, and somewhere else it's called telecommunication electronics, or something of that sort, right? And I don't know. And same with production engineering and civil engineering, and it kind of seems that people use different names. It's kind of not standardized. And the other one is board, right? Education boards. We split it up into three in this case. CBSE, ICSE, and the state boards. We kind of clubbed all of them together. The big problem was not having the state boards separately. The problem it would have given me is there would be very few observations in each one of them. The other problem that it was giving me is that, you know, it's very difficult to weed out human stupidity. All right? People type in all sorts of stuff. Okay, when you're working with text, yeah, that's one problem. You have a text field, people type in whatever they want to, and then there's very little you can do, you know, to clean that up. So it's better to be done manually. But the other stuff which we cleaned, it's all in the code, right? You'll be able to see that. Okay. Question 1, do we have any more missing values? Right. So that line 29, that sum is.na, okay, you can keep running it on different variables to figure out that if there are, I didn't import the data, sorry. If there are any missing values. The good part about this data set, because it's, you know, it's survey data and arguably a little cleaner than a lot of data that you would deal with in real life, especially scrape data, is that it's pretty clean. The only area where we found that there was missing data is the domain. Now, if you remember, if you see the data dictionary, domain is a skill test which was taken for these students. These students were taken, you know, they were asked to take tests by aspiring minds, one on English, one on logical reasoning, one on quantitative methods, and one on their individual domain. The domain test, there are a lot of missing values. Okay. Now, what do I do if I have a bunch of missing values? What would R do if there are a bunch of missing values and that particular variable is being used in my regression model? If that variable is not being used, then I don't care about it, right? There are missing values, people didn't answer a question, you know, they didn't participate in something, it's blank, I don't care about it. If I do use that particular variable, okay, what R would do is it would drop that row. It wouldn't use that row, all right? Now that we don't want. Now, what I'm going to do therefore is fill up those missing values for the domain scores with the mean value. Okay, because I don't want missing values. Now, if you talk to, okay, this is what it looks like, yeah? This is what the submission file looks like. Now, this is a simpler one, right? There are only 1,500, doesn't kill me, okay? And if you go do a Kaggle contest, there will be like, you know, probably 100,000 in there, but that's also okay. The story remains the same. You might have to use a little advanced technology, but you know, the math kind of remains the same. It doesn't kill you. Okay, but this is what a submission file in most Kaggle contests. This is what it looks like. And the first time I saw this, I was wondering what the hell do I do with it. As an economist, you don't do this stuff. Economists don't believe in predictions very much. Okay? They fit models. They don't do predictions. I never knew that you needed to actually break up a data into train and test sets till I, you know, completed all my masters and all of that, and went to work in the street. And then people were like, "Hey, where are your predictions?" And that's when I realized that, oh, this is something that you need to do. All right. So here's the submission file. Here's your results file. Copy this guy, yeah, and paste it here. Okay. All Done. Save it. And you're ready to submit. Okay. In this particular contest, what you have to do is you have to log in, and it will give you choose file, here's submission, click upload. That'll give you some terrible rank. It'll say you're like in number 3000 or something like that. Right? So that's okay. That's fine. Right. Did it upload? Yeah. So let's try it once again. And all of you guys can try that, and you can try it with any of those models. If you're brave enough, right at the bottom there's a spline-based model as well. You can use that. Same thing. Okay. Yes, it is uploading. You see that? Okay, and gives me a current rank of 50. Could everybody do that? Could everybody get to that step? Yes, no, maybe. Yes. Yes, yes, it does. It does. So do something. The easiest way to break it up is to just do it in Excel. Okay, no, not this. Hold on. So your result looks like this, yeah? It's just one column. Select this guy. On data, go to text to column. Next, and click on space. It's just space delimited. Right? What it did was, when I ran the R code, when I exported everything, right, it also exported the serial number right at the beginning, which it shouldn't have. Right? So I can write half a line of code and change that. But this is probably the easiest way to do it. Okay? Just open the CSV file. Make sure this guy is delimited. And it's delimited by space, and press finish. It's going to make it 2 columns. Okay. The one on the left is the serial number, and the one on the right is the salary prediction which came from your model. Now, the upside of the code that I shared with you is that it's very, very simple. It's ridiculously simple. Yeah? So go through it, run it, change the model, keep changing the model on whatever you think intuitively works, right? Stuff that works, variables that you think are useful. What does your salary really depend on? What do you think your salary really depends on? We see all sorts of funny stuff here, and some of them are fairly unsurprising, right? Some of them will be very surprising. Unsurprising results. Gender makes a difference. Of course, gender makes a difference. We know that. The world is run by idiots, so of course it does. But on the psychometric stuff, right? We added that in our models too. Okay, we added these in the model. So conscientiousness, agreeableness, extroversion, neuroticism, and openness to experience. We added these guys in our model as well to see that do these psychometric tests actually tell us something sensible or not. I question them all the time. Psychologists don't like me. I work with some of them. But anyway, now if you look at model 8, I think, or 7, any of these guys, yeah, let's run 7. Okay, and then go summary, salreg 7. Okay. Here my R-squared's gone up a little bit. It's about 15%. Now, economists won't dare try to sell this model to their journal articles. Right? They wouldn't. The R-squared looks terrible, unless you kind of do financial economics, but that's besides the point. However, we do find some level of significance on somewhat on conscientiousness, not so much on agreeableness. Neuroticism, not very important. That's great, right? Good. If you're kind of neurotic, you'll survive. Okay. So things like that, right? These wonderful results can pop out when you're running regression models. What can you do with this? Try out the code. Try out the submissions. Keep changing variables, see if you can come up with a better and better model. And that's all I have, I guess. Sorry about the technical glitches, which is kind of unsurprising. Anything you try to run on cloud never works. So, absolutely. Questions, comments, hate mail, anything. I will make sure that all of these, including the code, will be uploaded on the site. So just or I can mail it. Mail ask these guys to mail it out to you. Okay. The data is already there, of course. But I'll upload the code, and the presentation can be sent out to you. Yes. Yes, I have done a spline. Yes, there are a whole bunch of linear regression techniques other than this. So you can run a polynomial, you can run a log linear regression, you can run lasso regressions, you can run ridge regressions. There are all sorts of stuff that you can do depending on the quality, the type of errors that you're getting, and the distribution and things like that. So yes, you can do quite a few things. I mean, if you want a reference, feel free to email me. I'll put my email ID there. Yeah, yeah, I'll do that. I mean, so you can always on my email. Let's see. Okay, yeah. The Slack channel, yeah. Okay, hold on. You can, yeah, just use my bridge ID. Oh, yeah. Oh, sorry. White is it? Or the second one is, I guess, easier. But you can, yeah, email me on either of these guys. And can you see it? Kind of. The last one is my company email ID. I'm happy to answer emails. So if you want a reference for doing other kinds of linear models, there are a ton of them. Of course, advance warning, unless you know exactly what's going on and spend a little bit of time, it doesn't take a lot of time. It takes a little bit of time, but unless you spend that time, most often you would see that your linear regression model will give you outcomes which are very, very similar to the more advanced stuff. Not always, not always. So, but yeah, sure, I'll send you references. Yes, anybody else, anything else? Significance, yes, it shows you the degree of confidence that you have, right, about whether this certain variable is important in your model or not, and whether that certain variable actually affects, right, or is related to your dependent variable. The smaller the significance number, the more the stars, the smaller the number, the more confident you are. Confidence intervals. Just confidence intervals. Essentially the same story, right? Yes. We have used those as well. If you go to the models below, we have used multiple categorical models. We've used board, right? Which whether you went to ICSE or CBSE, we also use what's the other one? Oh, whether it's an MTech, MSc, or a BTech, or a MCA. The finding from this was that your master's degree did not add anything to your salary. Okay. And at that point, I was very upset that I spent so much time getting, multiple master's degrees, and I realized that they were completely useless. I should have, just kept doing what I was doing. It was a waste of time. But again, this is the first job data. So maybe your master's degree doesn't really add a lot to your first job. Maybe it affects what happens after 10 years much more. Right? So that's one way of thinking about it. That's how I comforted myself. Okay. Yes. No? Anything? No? All right. Again, we were a little pressed for time. Usually, we have a couple of partners who we run hackathons with. I'm usually the one sitting in the corner and being like, yeah, that sounds good. They run the hackathons, but usually it's about a 6-hour affair. It takes 5 to 6 hours to kind of go through this at a very normal way. But the idea was to get you guys at least excited, involved, get some R into the system. My preferred language, other than Bangla, which is which is the language that I speak. Yes, definitely, I prefer it over a lot of other languages, and a lot of engineers would kill me for saying this because they love Python so much. But R works. It's fantastic. Teach yourself R. It's not very difficult, and trust me, it'll help. Okay, even if you don't do anything related to data sciences, it'll help. All decision making is becoming data driven. All right, so if you, like most of you will land up in the IIMs and become managers, you won't do engineering. That is kind of given, right? We all know that. So as managers, I think data driven management, decision making is changing the world, and education is just one of those many things. So should be a good tool to have. Yeah. All right. Thank you.
So Deep, we can't tell you how fitting this session was given what happened yesterday evening. What do you guys think? After hearing the challenge problems from DPIO and Mr. Kant, this session I hope will help you. What do you guys think? Was it? Yeah? So what we will do is we have a Slack channel with mentors from Google, from IBM that are on, that have volunteered their time to answer questions specific to Google infrastructure, IBM infrastructure. We can make a data science Slack channel where people can ask analytics questions.
Okay.
And if you would be willing to respond
We'll do that.
to them,
We'll do that.
So guys, we will take care of that.
Just be prepared for some lag time.
Oh, yeah.
As opposed to R, which is pretty quick. There's other stuff.
No, and thank you for sharing not just the code and getting started, but also data sets. Because a very common question yesterday was, what data sets can we use? And so that was on one of your slides.
Yeah.
We'd love to be able to
Absolutely. I'll put up the slides. Yeah.
Great. So guys, we've come to the end of the in-person part of the hackathon. Can you guys hear? I don't know if this is on. Concept. Can you guys hear in the back? It's on now. It wasn't on earlier. All right. Thank you.
Not loud enough.
Did you guys hear me? Awesome. So we've come to the end of the in-person part of the hackathon. This is not the end of the hackathon overall. What I'd like to do as we conclude is to do another FAQ, but flipped on its head. So we're going to ask the question, and we'd like you to answer. Okay? Do any of you guys want to start with a question for the audience? I'll start. So what problems can you work on? In this hackathon, what problems can you work on? That's the most popular question that we've been getting. Can someone raise your hand and tell us, what problems are you allowed to solve in this hackathon? Yeah. Right. Okay, so that's an example of a problem you can work on. What is the high-level category? Education-related problems, and that's exactly right. So you can solve any problem in education. It does not have to be a problem that was named explicitly in the last 3 days. Is that part clear? We can reiterate what happened yesterday evening. Yesterday evening, Niti Aayog and Mr. Amitabh Kant announced 2 problems on top of the ones we've already been discussing. Those are above and beyond. You can win the hackathon prizes by solving any problem. If you solve the Niti Aayog problem, they have offered an extra prize for someone who solves it well. And that prize is that you are invited to an event that will feature the PM, it'll feature CEOs of top startups. It'll likely happen in mid-August, but date's not confirmed. But that's an advantage, that's an extra prize if you solve one of those 2 problems. There's a data science problem and there was a AI problem. And we will be posting those problems on our website at the end of this event later today. Okay? So you can solve any problem you want. If you've already started on a different one, not an issue. I wanted to reiterate that 10 times because that is the most popular question we get on Slack, on email, and in person. Any other questions you have for the audience? Go ahead.
So this is one thing which I really like asking after hackathons. So you've heard a ton of people since the day before yesterday, and even before that there was enough of excitement. What is it that you're taking back from this event right now, and what do you expect, say, post 4th of August? Want to answer that? Yeah, please. That's a big win. That's an extremely good thing actually, because you've got a mixed bag of both things together. Nice.
Kudos to Deep there.
Yeah.
I have a question. So on Friday when we started, a lot of you didn't have any ideas of what you wanted to build. Who now has an idea of what they want to build? Put your hand up. I want to see everyone have an idea. Someone who hasn't come up. Someone from there. I saw a hand. You want to come up? No? Well. Oh, come on up. So you want to tell us your name and your idea?
My name is Suraj, and my idea is basically there is a freely available data set available on Kaggle. It's basically EEG scan of brain of the students attending MOC courses. So basically, that data set, the problem statement is that using that data set, you have to predict the confusion state of the students. So basically, it was a competition hosted somewhere in around 2016. So basically, my in my team I have two other people. So basically, we wanted to make a model to make a better outcome out of it. Means there already exists some summations. We just want to make try our new model. So maybe we can come up with a better solution. No, we actually took this project somewhere like 15 20 days before. Yeah, yes. And because that project, we were working on that project, and this OpenEd AI came up. Like I saw it on Twitter. So basically, I just had to. Uh, Basically, we as a team of three people, we started on Kaggle doing random competitions. We like basically we are doing some competitions. So we came out with this problem, and we really liked it because we were very fascinated by EEG scans, and that too while students attending MOC courses, and we ourselves attend MOC courses. So like it was somewhere relatable to us. So,
So guys, did you hear his problem? You heard it. I think there's another dimension you can look at, and I don't know if the data set exists. You might have to create it, but if you imagine a webcam scanning eye motion, where it rests and how the eye dilates and whatnot while someone is viewing a video course, it might be annoying to collect the data, but if you create that data set, I can imagine it being very valuable. Create or find a small sample and try to analyze it while someone's watching a MOOC, a video, to understand what would happen.
if they are not distracted.
Yeah, attention, engagement, sleepiness.
So, I recently had this auto show going on in USA. So basically,
You can speak into this so they can hear you.
so what Anshus has said. So basically, I just wanted to add up to that. Basically, there's a auto shows going in currently in USA. So basically, there's a motor company that developed a semi-automated self-driving vehicle. So basically, they came up with this system. Where if the driver is not looking at the road, so basically a message pops up. So basically, they train their model to detect where your focus is. So basically, it will be a very nice idea to migrate that application towards.
There you go. Yeah.
Okay.
Good. Good luck. Question from me. By when do you have to submit and how? By when do you have to submit your project and how do you submit? Cool. That's pretty close. I'll just add one thing to it. Any other answers? Yeah.
An econometrician or a statistician, or if you were writing an academic paper, they would kill you for doing this. Okay, but in the industry we are not as rigorous. We get by with a lot of pap. Yeah, academics would kill us for doing this. So what do we do? Lines 33 to 39 essentially looks through column by column that what's blank in my data set. The first 3 lines of code for the training data, and the second 3 lines of code for the test data. All right, and looks through that where I have missing data, okay, and fills it up with the mean value. All right, you'll get a bunch of warnings once you run these lines of code, and the reason why you would find a bunch of warnings is because it'll tell you that a lot of these variables are not numeric, so you cannot actually have means for them. Right? Okay. The good part though is in this data set, the only thing that has a bunch of missing values is domain. Okay, they're domain tests because a lot of people didn't take the domain level skill test. We're just substituting that with means. Okay. All right. So I'm gonna walk you through a few more steps on data cleaning and so on. Run your first regression model with me, okay? And after that, you can run it on your own. All right? What we call it is it's like a fishing expedition, and I'll tell you why it's like a fishing expedition. Okay. All right. So what we do next is run this little graph. What the pairs command does is all the variables that I mentioned in there, right? It does binary graphs for each one of them, okay? So you'll have a 4 by 4 or 5 by 5, and if you want to do 10 of these, you'll have a 10 by 10. And each of these graphs compare the scatter plot for 2 of these variables, right? So this guy is salary and 10th grade percentage. Okay, this guy is salary and college GPA. Because what I'm trying to figure out by looking at these paired graphs is that are these variables related to each other or not visually? Okay, and there are of course many quantitative ways of doing it, but that's the first step I take. And even before I can think of the relationship, something else pops up when I look at the college GPA. If you look at the graphs for college GPA, there's something very unique about these. Can anybody tell me why? And you can see it on your screens. Something that bothers me. And if you read the data description well enough, you would know immediately what's bothering me or what would bother you. Yes? Think about it. Take a look at it. Yes? Forget about the relationship even. Forget about the relationship. Just, yeah, high salary, bad college, that's bad GPA, that's great for people like me who barely scraped through their undergrads and masters. Good for me, right? But there's something else. And you might have, you know, what you're looking at the data is true. You're right? There's something wrong there. That you have very low GPAs, right? Does everybody see that? So here's my scale, okay? For college GPA, it's 20 to 80 out here. So it's essentially 0 to 100. And I have these bunch of characters here who have college GPA of less than 20, close to 0. Why is that? Are they flunkies like myself who dropouts. No, the scale. It's the scale. These guys did nothing wrong. They went to a college which graded them on 0 to 10 instead of 0 to 100. So they're not like, the riffraff, who just kind of scraped through. They are essentially kids who went to colleges where the scale is different. Okay? Now again, yes. Yes. No, we did the opposite. We did the opposite of that. In the test data set. Yes. So don't worry about the test data set right now. Okay? Looking at just the train. We'll come to the test data set. We'll talk about that, absolutely. And what we're doing is just the opposite. What these guys have done is they have encoded all missing variables as -1. Right? So, which is kind of stupid, but okay. So what do we have? We know from the data dictionary and obviously by looking at this that there are some colleges who use the 0 to 10 scale as opposed to 0 to 100. This one, the data set thankfully has only two kinds, 0 to 10 and 0 to 100, because there can be multiple kinds. There are 4-point GPAs and things like that, right? Which would have made it even more complicated. So what we do here is, for all GPA less than equal to 10, we multiply it by the number 10. What's the heuristic that we are using here? The simple heuristic is that if you had a GPA of less than 10 in a 100-point scale, you wouldn't be going for a job interview. Okay? So anyone who received some grade which is less than 10, we multiply their grade by 10, and that's because we know that there are only two kinds of scales used. One is out of 100, one is out of 10. We already know that from the data dictionary. If we did not, we have to split this process up because there will be people with a 4 GPA, right? 0 to 4. All right? Okay. So if you run the code on lines 48 and 49, okay? These two guys. That should take care of. Okay, that's fine. No worries. It'll warn you about something or the other. I'll ignore that for now. Okay. All right. Now I'm going to go back to something more basic. So there are two things that you look at when you are running these models, right? One is the fit of the model on the existing data set that you're using. How good does it fit the data? Okay. And the second thing that you see is how good does it work when you're running it on some outside sample, not on your own data, but the test data, outside data. All right? So the easiest way, one of the easiest ways, to measure how good a fit is, okay, this model is on this data set is something that's called an R-squared, right? Now, I won't go into the details of what is an R-squared and all of that stuff, okay, because we have 15 minutes, okay, and we won't do that. But we will, use it, and when you are participating in the data science contest, this is one metric that you'd be using over and over again. What the R-squared says, very simply, is that what percentage of the data is explained by the model. Essentially, it's a metric out of 0 to 100 on how good your model is on your existing data set. Okay? So 100% means it's fantastic. 0% means it explains nothing. Usually a very, very high R-squared means that you have screwed up somewhere, okay? Because your model is usually not that good. Don't trust your model too much, right? Okay. Now, so here's my first regression model that I'm going to use, okay? SalReg is my name. You can call it whatever else that you want to. This is the name that I have given it. LM is the command in R that allows you to run a linear regression model. Okay. The first variable within the bracket is salary. Why salary? Why not anything else? It's your dependent variable, right? Absolutely. That's what we are trying to explain. And on the right, I have a variety of things which we think might affect, that's a hypothesis, we don't know yet, right? Which might affect my salary, right? And what are those things? I begin with a few. I begin with my 10th grade GPA, my college GPA, my 12th grade GPA, and my graduation year. I use graduation as a proxy for age. The hypothesis is that older people, maybe they are in the job market for longer and they earn more money. Okay. And then what I do is I run my first linear regression model. You can do the same. Okay, good. And it has created, under values on the right in the global environment thingy, you can see that it has created something called a salreg. That's your regression model. Okay, that's the output from your regression model. Okay, now, how do I read that guy? Yeah? So just type in summary, aim of your regression model, yeah, and press enter. And it's going to give you something that looks like this. Okay? Summary, the word summary, and then brackets, the name of the regression model that you just ran. Okay, and whatever you want, whatever you call it. In my case, I called it salreg, and I only had 1, 2, 3, 4 independent variables, and I ran a model. Okay. Now, key things to look at here. 3 things. Okay. This estimate tells you the relationship or the size of the relationship between your dependent and your independent variables. Okay? The size of the relationship between your dependent and independent variables. This guy on the right tells you how significant they are statistically. Okay? In short, are they useful or not? Do they actually do the job or not do the job? Does this estimate actually mean anything or not? What's the significant code? The significance code essentially means that what level of confidence do you have, okay, when you say that this particular variable affects my dependent variable, right? Now, a single star means at the 5% level, so single star means 0.05, okay. What does that mean? That if there is a star next to my variable, a single star, I can be confident at the 95% level, right, 1 minus my 0.05, that this particular variable affects my dependent variable. All right? 2 stars is at the 1% level and so on, right? So bigger the number of stars, more we like it. Thumb rule, which makes sense. Okay. The other thing that I want you to look at is something called, which we talked about, is your adjusted R-squared. Right? And what's your adjusted R-squared here? You have all run the model. Can you see it on your computers? Could you run the model? Could you see what the adjusted R-squared is? Okay, right. So your model essentially explains about 3.5% or less than 4% of your data. Right? So it's essentially a terrible, terrible model. Okay. So these 3 or 4 attributes do not do a very good job of explaining what your salary will be or predicting what your salary will be. That's what this model tells me. What it also tells me is that my 10th grade percentage and 12th grade percentage might be important. My college GPA does not seem very important for my salary. Okay? I will run a whole bunch of models. Okay. Now, when you run regression models, and this is one thing that, and I talked about this a little while back, that why don't I like data science competitions, right? I mentioned that. that I don't like data science contests. And the reason why I do not like data science contests, or this perspective of doing data science or machine learning or whatever have you, is that you just ignore, okay, these many assumptions that we make when we run a model like this. And it's impossible to cover that in 10 minutes, in 10 hours, 10 days. It takes a really long time to understand what those assumptions are. And we all do that, right? Whenever we get data, we run some R code and come up with a linear regression model because that's the easiest thing to do. And everybody loves linear regressions. They're so intuitive. Everybody can understand. Does A affect B? You can write a model like this and say, hey, look, I found something great. College GPA doesn't predict my salary. Wonderful. Right? And people think that that's great insight. Yeah. So we love running linear regression models. But linear regression models have a variety of underlying assumptions. Okay. Now, read about those. That's all I can say. Read about those. Like we mentioned one here, and that's we run this test for multicollinearity, okay, which is the variance inflation factor, VIF. And if you run some of the later models, you will see that you'll see some level of multicollinearity. What does multicollinearity tell me? Multicollinearity tells me that how correlated are my independent variables in the model. Okay? If these independent variables are very highly correlated, then I'll get muddled effects from them, right? Because these two guys, which are both a part of my model, are moving in tandem. So the effect of each one of them individually on my dependent variable is lost out, right? The VIF essentially measures how related are these different independent variables in my model, okay? And thumb rule again, because we live in a world of thumb rules, VIF above 10 sucks, anything less than 10, anything less than 5 is great, anywhere between 5 and 10 we can kind of live with, okay? So the good thing is here my VIFs are low. Now what we have here after that, okay, if you keep looking at the code in front of you, is that we have a variety of these models that we run. The idea behind running these models is, and here I have a limited number of variables, so I can try them all. I can use a brute force method. I can keep trying them all. But when you have lots and lots of variables, you cannot do that. The idea behind running these models is, what's my intuition? The downside of using intuition is we all know that, what do you know, from the nursing school story in Atlanta, Georgia, that intuition often sucks. Right? We use all sorts of very biased ways of doing things. Okay, all right. So what I'm going to do is I'm going to leave it here. But one thing I'll show you before I leave, because we have about 5 to 7 minutes, is how do you submit a solution? Once I've run my regression, okay, on my training data set, I use the same thing to predict what's happening to salaries on my test data set. All right? Once I have done that, I want to submit and see the quality or the performance of my model. So I'm going to pick up one of these models, salary 5, and run that. Okay. And then I use the predict command, which is in line 73. What the predict command tells me is that predict what's happening to salary, okay, because R already knows what my dependent variable is. Predict what's happening to salaries in that data set there, which is AMEO test, okay, based on the model that I just created, which is salary 5. I created a model, and that model depended on a variety of things, 10th grade percentage, 12th grade percentage, gender, college city tier, so on and so forth. If you look at the models, the gender is significant. You'll see that, right? Women coming out of engineering schools actually make less money. We knew that, but our model says the same thing. Okay, So that's your prediction step. I've run my regression model. I want to predict in a data set which is completely outside of this system, right? So I take the model that I have right now run, and I run it on my test data using the predict command. Okay, that's done. My prediction's done. I'm happy. Good. How good is my prediction? How am I going to find that out? I'm going to use the write.table function here, okay? And I'm saving the results from the predict function, all right? So once you do that, you'll find a CSV file which kind of looks like this. Let's see. I'm going to move it, do a text to column on this because it has, for some reason, given me. So that's my ID number, the serial number in column A, and in column B, I have the salary predictions, yeah? Okay. Column B has the salary predictions based on the test data. Remember, in the test data set, I didn't have the salary data. They were marked with question marks. Okay, I didn't have the data for the salaries. I'm trying to predict what those salaries are of those people based on the attributes that I have seen here. Okay. All right, good. Now, how do I create a submission? If you have seen the leaderboard web page, okay, where is it? Yeah, this guy. Okay. There is an Excel file. I'd like you to download that. Submission, SX, and I'm going to open that.